Okay, dokes, we are on the air.
Cool.
Okay, so I need to finish writing this down. Okay, okay. Oh, number 3, correct?
Yeah.
Okay. 21 questions. You got. Yeah.
I know.
Okay, I'm so hungry. Which hypothesis involves equality? The null hypothesis includes equality. Correcto? Yes?
That's
No?
what
Yep.
I put.
Okay, number 4.
I could read it. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as one that was actually observed. When computing the p-value, which hypothesis do you assume to be true, the null or the alternative?
The P, isn't it
Null.
null, right?
That's what I said.
Okay. Which of the following represents the alternative hypothesis for a two-tailed test with the information above it?
Two-tailed test. I'll go back to my notes. There's a U.
If you go to 4.3.2 in the chapter, it gives a good graphic example for this.
Oh, I see. That's what I was getting to.
Because I like these pictures because it helps me see what the difference between the null and the alternative is.
Yeah.
So then the two-tailed would be the not equals.
Oh, I see. Yeah. I need to write all those down. Number 6, so which the alternative for left-tailed test, that would be the less than sign.
Yeah.
Yes.
You guys like how I have to do the this left? Good job, Chase. Thank you. Okay, the right-tailed is the greater than.
My whole life, I've struggled with the less than and greater than signs. I get so confused with them.
Me too.
My whole life.
My whole life.
It's so true. Still, even now, I have to sit there and think about it.
Sometimes I have to just Google it because I'll get frustrated and I'll think about it all day. And I'm like, okay, but wait.
Yeah. Same.
I don't have that big of a problem with them, so I'm glad.
I'm glad you don't either. Hopefully.
I get mixed up with my left and right really bad, so it's just a challenge.
That's pretty good.
Okay. Remember that we determine the outcome of the hypothesis test by comparing the p-value to the level of significance, or A, use this information. So the relationship would result in failing to reject the null hypothesis. Which relationship?
When you look at this, relationship would result in failing to reject the null hypothesis.
Oh, okay. In the next section after those graphs, It says, if the p-value is less than a, we reject the null hypothesis. Conversely, if the p-value is greater than a, we fail to reject the null hypothesis. So it should be option 1, right?
Yeah.
Yeah.
That's kind of confusing because it's like fail to reject and then just reject.
Oh, I know.
So
which one's the opposite?
question 9 is which one is rejecting. So
it's number 2.
You should write those down. Sorry, I was writing this down. You guys can keep going. I can catch up.
Okay. So, insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be appropriate alternative hypothesis? HA.
So isn't it 3? The average claim amount is greater than 1,500.
So
Yeah.
if they're gonna appropriate alternative, because they think it's actually higher, yeah.
Yeah, so they just said so. Cool.
Which of the following would be appropriate null hypothesis? It's that it is equal to, right?
Mm-hmm.
Yeah, I think so.
Or would it be say that it's, does null hypothesis have to do with the not equality as well? Or just equality?
That not equal to is an alternative one, because that's the double one. The two-sided one.
The higher term can be include greater than, less than, or not equal. Yeah. Okay. Perfect. The insurance company randomly selects n equals 40 claims and calculates the sample mean of x equals $1,650. Use the information to answer the next 3 questions. So the insurance company assumes the distribution of sample mean is normal. Is this a good assumption?
Isn't it the first one?
If the sample size is large, that's what I was thinking.
Because it's bigger than what, 30 or something? So that means it's normal.
Greater than 30.
Mm-hmm.
Sample size. Yeah. Okay. And that's the central limit theorem.
Yep.
Which of the following is the test statistic as defined in this lesson?
The statistic?
This is called the test statistic. The X with the line over, is that, yeah, the first one. I'm looking at the book 4.2 test statistic. Did you guys think that's right?
Yeah.
Yeah.
I don't know. Now I'm seeing different. No, yeah, okay.
Wait, I think it might be Z.
Oh, yeah.
Z
where Z
equals
is.
The test statistics, X is the sample mean.
Good catch.
Okay.
Okay. So the historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. He sets up a hypothesis test with this hypothesis. She will use a level of significance of A equals 0.05. Then she takes a simple random sample of 36 sales receipts from her store and computes x equals $144. So what is the z-score associated with this test?
How do you figure it out with the A? Or is that not important?
Let's look and see. I still have that memorized. My notes right here. Value, would it be the value? No, the value is 144, huh? No, wait. So the mean is 150. Standard deviation is 40. So would the value be 144 or the 0.05? Or 36?
I think the value is 144.
Yep. Okay, yeah. Well, 144 minus 150 equals -6 divided by
I think I just need to state it.
40.
Basically, I'm looking through for the chapter. I don't think we actually use it. We still just compute the
Yeah, looks like.
it would be the one. Well, we'd have to find out the new standard deviation by doing the square root of 36, which is 6. And so then the standard deviation divided by 6. So 40 divided by 6.
I think I did -6 divided by 40.
Wait, where'd you get the -6 from?
Because I went 144 minus 150.
Oh, yeah.
-6, and then I divided it by 40.
Oh.
But do we, since the random sample is n equals 36, don't we need to find the new standard deviation?
That is a possibility.
I'm willing to try either. I have no idea.
I think we have to find the new standard deviation to find this.
Yeah. No, I think that's right. Yeah, because it's a different. Okay.
Because it would just be 40 divided by 6, because the square root of 36 is 6.
So the new standard deviation is
Should be like 6.6 repeated. That's what I got.
and then you would plug in the -6, right? But then you would
So the -6 divided by that.
by the 6.6666. Yeah, so then you would get like the -9.
-0.9. Yeah, that's what I got.
Okay. Awesome.
Okay, well. That's fine. We can do without it.
So what's the p-value associated with the z-score?
The p-value.
Okay, p-value is calculated.
The area.
Yeah, by the area.
And the total above.
From the z-score.
Yeah. So we would put in that, but we would put in the new one, right? This 6.6.
What?
Why don't we put in the new z-score?
Yeah, so we put in the answer to 15, I believe, the -0.9.
Oh, yeah.
Yeah.
And then do we need to have, I'm trying to think, in both the left and right tails?
I think just the left tail.
I'm trying to read the p-value is the probability of obtaining. Oh, that's in the case of a two-sided. Okay, yeah.
So it's just the left one?
I think so, because the
Mm-hmm.
alternative hypothesis is U is less than 150.
Okay. Did you guys get 0.1841?
Yes.
Okay. Let me round to 3 decimal places, so
So it'd be 0.184.
yeah.
Huh?
Okay, what inference would you make about the null hypothesis from this problem? To reject the null hypothesis or fail to reject the null hypothesis?
Was the p-value greater than A? Let's look. So A was 0.45 and it's smaller, so
Wait.
we would reject it.
Wait, what'd you say the p-value was?
0.5, right?
Oh no,
Wait.
the p-value is the 0.184.
Okay, I
Oh,
was like, I'm so
I'm like
confused.
reading this A up here. I don't know why
Oh,
I
you're
keep wanting
fine.
to
I
read
was just
that.
like, wait, that's not what I put for my p-value. I'm so
Oh,
confused.
okay.
No, you're fine. I was just confused.
But so then I was thinking of it. So we have the 1.184, and that is greater than.
Yeah.
so then we would fail to reject, right?
That's if it's less than.
Oh,
Oh, fail to reject. Yes, yes, yes.
okay.
See, they are too close. Reject or fail to reject. Like that just is too close for me.
No,
You
I
should
agree.
have picked a whole different word instead of reject. They should have just said like accept or something.
That's true.
Yeah.
So, what is your conclusion for this problem? We have sufficient evidence that the true population mean is 150. The first two, I think, are the same. Oh, sorry, insufficient.
Yeah.
Sufficient. Then we have insufficient evidence that the true population mean is less than, and we have sufficient that the mean is less than.
We have insufficient evidence that the true population mean is less than 150.
Yeah.
Maybe not.
Some butter on it.
I think so. We have insufficient evidence that the true population mean is less than 150.
Yeah, that sounds right. Or is it sufficient evidence? I don't know.
I think insufficient because it's the failing to reject. I don't know.
I have no clue. I'm trying to go through.
I know I'm skimming the chat, going back through the chapter to see.
Mm.
don't know. We can just guess and then I don't know.
Sounds good.
Sounds good to me.
Okay, what are the two types of errors that can be made when performing a hypothesis test? Which one involves rejecting the null hypothesis when the null hypothesis is true? Type 1 or type 2? Just
Type 1.
yeah. Yeah.
Which involves rejecting the null with the hypothesis, so type 1. The research decided that instead of using a level of significance of A equals 0.05, he will use A equals 0.01. Which of the following will be true? Type reject. Not true. So, really true. Not true. Does it have anything to do with the fact that it's becoming a? I don't know. Because what are you doing? Because
I think it's the probability of type 2 will increase, but
that's why I had marked. Because I don't. Because it adds more chance that things are gonna that it's not gonna be true.
yeah, and then the chapter says A value is very small, so he decreased that A value.
Mm-hmm.
The probability of committing a type 2 error will be large, so you would increase it, right?
Yeah. Look.
I don't know, that's what my thought is.
Let's try it. That makes the most sense to me. I don't. Yeah, I'm not sure.
If for A compute the probability of committing a type 1 error. What section did you find that in, Kylie?
Section 4.5, type 1 and type 2
Yeah,
errors.
there we go.
I mean, it says we choose A so that the probability of committing a type 1 error is low, but it doesn't. Oh, the most common value for A is 8.05. Yeah. So this is equal to 1 over 20. So in the null hypothesis, there is a 1 in 20 chance that it will be rejected at the 0.05 level. Other common choices. Okay, so that's not. So that might be it. No, maybe not.
I was trying to figure out how to solve number 21.
Yeah, that's what I thought I was going to talk about, but just that last paragraph right before it's like if committing a type 1 error is undesirable. That's what I thought it was going to talk about.
The value of A is the probability of committing a type 1 error. So wouldn't it just be 0.05?
That's what I'm thinking.
That's what I'm going to put. It's worth a shot because I don't see any equation of how to compute it.
I see where you read that just kind of above scenario 1, right?
I
Yeah.
actually read that in the remember part down in the summary. It's like the very last statement.
The value of A of the probabilities value of A is the probability of committing a type 1 error.
Okay, so it's
So it's 0.05.
okay, cool.
I think so.
Okay. Shall we try it?
Yeah.
Do you want me to leave mine open again, or I can submit this time? It doesn't matter.
It doesn't matter. I can leave mine open this time.
Okay.
We got 100%.
Oh, really?
Yeah.
You're like, oh, really?
Yeah.
Well, we're not used to taking it twice, so.
I know.
Oh, well, okay.
Look
Well,
at that.
Yay for us. Yay, yay, yay. Okay,
Cool.
cool. Well, I guess I can go eat now.
Sounds good. I'm glad this was short so you can go eat.
Me too.
Okay. see
Okay,
you
I'll
guys.
see y'all on Tuesday.
Bye.
Bye.